Right, welcome back, everybody. I believe this has worked, and Simon has joined us again as well. So yeah, we're looking good. But I'll hand over to Simon again for the start of the second session. Thank you very much.
Welcome back, everyone, and I hope that breakout session was useful for you, and hopefully you had some good discussions and maybe a few, maybe spoke at a few good contacts. So I'd now like to welcome up onto the stage Fergal Harrington-Beatty, who is the head of automotive and aerospace at AMTE Power, and he's going to give us an overview of the next generation of high performance cells in the UK. So over to Fergal.
Apologies while I try and find him.
You're on mute.
I shouldn't be. Right, I'm just trying to find Fergal in the list. I'll invite him in a second. Bear with me 1 second, please. All sorry.
Hopefully you found the discussion points this morning quite useful. We had lots of Q&A, thank you, which obviously makes it much more interesting, especially for putting the speakers on their toes, so to speak. I think the two presentations this afternoon are going to be quite interesting, looking at sort of manufacturing capability and industrialisation here in the UK. Hopefully, here comes Fergal.
Hi there.
Hi, Fergal.
I'm 644, so I'm not usually hard to find, so that makes a change. I will share my screen.
Excellent.
So good afternoon, everyone. Thank you for joining me today at the State of Play Batteries event. My name is Fergal Harrington-Beatty, and as Simon said, I'm AMTE's head of automotive and aerospace. And today I will be discussing AMTE Power, the next generation of high-performance battery cells in the UK. So today I will touch on the state of the current UK battery market, introduce you to AMTE Power, describe our ultra-high power cells and ultra-energy cells, our scale-up objectives, and how we're implementing them with the FERSO Plus project, and highlight some of the conclusions we've made so far. I hope today's presentation gives you an idea of the scale of the challenge faced by AMTE Power and other cell manufacturers looking to scale up in the UK, but also the huge opportunities that are available. So, the state of the UK battery sector. Where are we today? Currently, we know that automotive manufacturing is a mainstay of the UK economy, accounting for £82 billion in turnover in 2018 and more than 14% of exports. The Faraday Institution expects that importance to grow over the next 2 decades, and the UK could be producing 1.6 million electric vehicles annually by 2040. It's often argued that we do not need the volume battery sector, and they would be sufficient to target electric motors to retain jobs. As the battery is the key component of the electric vehicle, I think we should aim to onshore this production in the UK. So, the projected demand in the UK battery sector. The charts in this slide have been taken from a Faraday Institute Insight report. AMTE is a member of the Faraday cohort, and our Gigafactory feasibility project and niche battery projects have been a great success. I'll touch more on our collaborative R&D projects later. Figure 1 describes global battery manufacturing supply to 2030 and shows that, contrary to what one may believe, Europe is expected to become the world's second biggest battery producer, even exceeding the USA. This is because of demand from domestic nations and the existing automotive sector in Europe. Figure 2 shows that a swathe of new gigafactories are planned worldwide. This dates back from 2019, so there have been multiple new announcements since that graphic was produced. And figure 3 shows gigafactory demand in the UK. So this chart assumes each gigafactory will take up 15 gigawatt hours of supply and shows the scale of the challenge that the UK has in encouraging domestic and international battery suppliers to set up in the UK and provide this gigawatt hours of demand. So, knowing this, how does AMTE Power seek to address this? First and foremost, our vision is to be a leader in innovative battery cell solutions, and our mission is to bring highly differentiated battery cell products to market and be the supplier of choice for clients in niche and scalable markets that are not fully supported by the existing supply chain, or where there are still gigawatt hours worth of supply potential. At AMTE, we know the UK niche vehicle manufacturing sector has been instrumental in helping accelerate the rate of innovation across a wide range of new low-carbon vehicle technologies, and we want to support this with our ultra range of cells. Now I've established the demand AMTE is looking to address, I'll give us a brief intro. So AMTE Power can trace its history right back to the invention of the lithium-ion battery. We were founded in 2013 by Kevin Brundish, Steve Farmer, and Ian Whiting. We acquired AGM Batteries, a production-scale manufacturing facility in Thurso, Scotland. And we also have an established R&D facility in Oxford and a London sales office that will be reopened in line with COVID regulations. Our strategy is to combine high-level skills with an access to a portfolio of world-leading cell chemistry and energy storage IP. It is also to develop and commercialize high-value technologies in massive growth markets, for example, the automotive, aerospace, and stationary storage sectors. So our history is quite interesting, so I'll give you a bit more of a detailed background to that. So in 1979, John Goodenough demonstrated a rechargeable lithium cell with a voltage of 4 volts and using lithium cobalt dioxide as a positive electrode and lithium metal as the negative electrode, so the cathode and the anode. In 1991, Sony released the first commercial lithium-ion battery, and in 1998, AGM Batteries was formed as a joint venture between ABSL, GS Yuasa, and Mitsubishi Materials. In 2007, ABSL took control of AGM, who were then procured by Enesis in 2011. In 2013, AMTE Power was formed, and in that same year, AMTE took over AGM. Production was restarted in 2015 at AGM's Thurso plant, and we released our ultracell range in 2019. Bring products to market at Thurso. So our highly flexible cell production facility in Thurso has a strong track record in commercializing new products and IP and low volume batch cell supply. The facility can accommodate a range of chemistries and manufacture both cylindrical and pouch cell format, both rechargeable and non-rechargeable cells. Scaling to ensure supply meets demand. So AMTE's existing manufacturing HQ in Thurso can address the initial hand build and small volume manufacturing of lithium-ion and sodium-ion cells. Thurso Plus seeks to expand our plant's capability and will be discussed later in this presentation. As we scale up, we will look to utilise UKBIC, which will be discussed today by Andrew Britton. AMTE's Gigafactory will be designed in a modular fashion, supporting multiple high-performance cells rather than just a single cell. AMTE also has a microfactory manufacturing model, which will potentially allow us to co-locate with module and battery production facilities, both in the UK and the rest of the world. So our UK-based Gigafactory will look to directly employ 160 to 200 skilled people. And we've done the study for the UK-based Gigafactory on a Faraday Round 3 Gigafactory feasibility project, and the model created out of that project is the basis for our Gigafactory. So our plans have a good level of detail. We then expect this to support a further 600 to 1,000 jobs throughout the wider supply chain, which will include material suppliers upstream and also part manufacturers and automotive OEMs downstream, and end-of-life management companies. We hope it will create a cornerstone of cell manufacturing, which will be vital to enable UK OEMs a future existence in the UK and strong export growth. As I said, we've been working towards this Gigafactory since 2018, and using our extensive experience in the battery sector and our homegrown cell IP, which is unique to AMTE as a UK cell manufacturer. Our AIM listing in March will also provide significant investment behind this and our ultra-cell products. We hope our Gigafactory will provide the economies of scale for high performance and niche vehicle manufacturers, as highlighted by Danson from Danica, that's currently lacking. So high performance battery cells at high value markets, targeted at high value markets. Our UHP cell is aimed at high performance hybrid and fuel cell vehicles, both in the automotive and aerospace sectors. So AMTE will manufacture 2 pouch cell variants, one in a lower volume, our Thurso facility, and a larger VDA standard cell at the UKBIC. Our Ultra Energy cell is targeting market leading energy density in a 21700 format, and will be suitable for both battery electric vehicles and energy storage applications, such as stationary storage. Our ultra-safe cells utilize unique sodium-ion chemistries, as mentioned by Emma earlier, that made them suitable for safety-critical applications. Sodium-ion structure allows for these cells to be fully discharged to 0 volts, which is unique and means the cells can be transported far more safely than their lithium-ion equivalents, because they then don't pose a risk with thermal runaway. So our motivation is to do more than simply address the domestic battery demand in the UK. Our ultra cell range focuses on improving on the current generation of lithium-ion cells by innovating in the way that the cells are constructed at an internal level and that the materials are used to do this. This allows both our power and energy cells to operate with greater respective power and energy densities. Current lithium-ion cells have relatively high internal resistances. This means that extreme fast charging and discharging of cells is not possible without overheating and possibly failure. And the GIF on the right shows quite a dramatic example of what can happen when a cylindrical 18650 cell overheats and enters thermal runaway. These high levels of internal resistance are what are limiting lithium-ion cells in current EV powertrain applications. So our ultra-high power cell is one of our most exciting cell products. Using unique IP, which we have the exclusive rights to, our engineers have designed a cell with very low internal resistances, which can allow for up to 100 C discharge rates, increasing the rate at which cells can release power significantly. This cell far outperforms other cells in other comparable cells. Up to 30 other comparable cells it performed better than, and this was in a study conducted by a hypercar manufacturer. As our cells produce more power than anything else on the market, they allow manufacturers to downsize the engines in their hybrid vehicles, hence saving CO2 and reducing weight, whilst increasing performance. In addition to hybrid ICE vehicles, the cells are also well suited for fuel cell vehicle applications, which we expect to initially see in SUVs. A few of these fuel cell SUVs have been announced, and also larger vehicles. So just a quick explanation of how power density works. So if a system has a high power density, then it can output large amounts of energy based on its mass. For example, a tiny capacitor may have the same power output as a large battery, but given the capacitor is so much smaller, it gives it a higher power density. Since these capacities can release since these systems can release their energy quickly, high power density systems can also recharge just as quickly in some cases. Hence, for those designing automated performance powertrains, they were previously stuck choosing between either energy cells with a low discharge capability or power cells with still a relatively low discharge capability, with then quite a jump to supercapacitors when requiring very high discharge. But unfortunately, these supercapacitors have very little usable energy density. AMTE's UHP cell seeks to address this gap by providing power density upwards of 1000 watts per kilogram, but still with usable energy density at 120 watt hours per kilogram, as this slide shows. So the first generation of AMTE's UHP cell has been tested at Millbrook Proving Ground, and it performed very well in testing, indicating a power density, as I said, of more than 1,000 watt-hours per kilogram. As demonstrated in this plot, is significantly more than current generation cells from A123, Murata, Saft, and Toshiba. Also worth a mention is our Ultra Energy cell, which is currently based in the 21700 format. So with this cell, we're targeting next generation performance in volumetric and gravimetric energy density, as well as higher capacities. So we're talking about upwards of 800 watt-hours per kilogram and, upwards of 300 watt-hours per kilogram and 800 watt-hours per litre. As with the UHP cell, this allows packs to be downsized or increased in capacity and performance. And this Ultra Energy cell was developed on the niche battery project, which I will discuss shortly. So all of AMTE's R&D is focused on developing core products into next generation variants that can compete in a global market across various sectors, in addition to scaling the company towards high volume production. So I've personally led all of AMTE's grant-funded project creation as our only bid writer since January 2020, and will lead you through some of the R&D projects described in this slide. Just for everyone's information, the innovate, commercialize, and supply arrows at the bottom represent an increasing TRL level. So one of our early stage projects, our gigawatt-hour cell manufacturing feasibility project, has formed the basis of our gigawatt-hour facility production. So it's been very useful. We've also worked on acoustic battery testing. So this is a current ATF project, and looking at the feasibility of that for gigafactory cell manufacturing. We are also currently working on quantum sensors for end-of-line battery testing as part of the commercializing quantum technology core. One of our current most successful projects is wrapping up, which has been the niche vehicle battery supply chain project. We've also studied changing our pouch cell architectures for extremely fast charging as part of a Strand 2 competition, and also working on with companies like Brill Power on innovative BMS modules with our Strand 2 work. At higher TRLs, our Ultra APC 16 project, which will start shortly, will support the development of our Ultra Energy and Ultra High Power cells. And our Thurso Plus project has been designed to develop the expansion and feasibility of our Thurso plant. So having briefed you on the current UK battery sector and on AMTE Power and our cell products, I will now describe our current scale-up objectives and how we are addressing them on the Automotive Transformation Fund, i.e. the ATF, our Thurso Plus project. So Thurso Plus is demonstrating innovation in the development of a lean, flexible and state-of-the-art high-volume cell manufacturing capability in the UK, which is currently lacking. There is innovation in the adoption of high-volume manufacturing techniques and process within a small-scale facility. The plan of this is to reduce scale-up costs by minimizing development and trials and increasing production quantity. And this project is made up of AMTE Power, cell manufacturer, and the High Speed Sustainable Manufacturing Institute, HSMI, who are experts in high-volume and scale-up manufacturing. So prior to starting Thurso Plus, AMTE's production director and industrialisation leads identified 3 major scale-up objectives that AMTE must address. So these are immediate productivity improvements, the mimicking of gigafactory processes for faster implementation as we scale up, and maximising potential plant capacity. So scale-up objective 1, immediate productivity improvements. In order to scale up production to successfully meet ramping demand, AMTE is identifying and implementing immediate opportunities for productivity and efficiency improvements through lean manufacturing principles. This is done using existing cell manufacturing expertise in collaboration with partners with high volume experts like HSMI, who utilize manufacturing simulation software like AnyLogic and Witness. The key implementation tasks include the production audit, a line assessment review, and the development and implementation of productivity enhancement solutions. Scale-up objective 2 is to mimic gigafactory processes for faster implementation. So AMTE and HSMI are currently identifying processes, procedures, and methodologies that can be adapted within the Thurso facility to mimic and align with state-of-the-art gigafactories. So key tasks currently underway are the trial and assessment of a pan mixer versus our current planetary mixer. So that pan mixer is used more in high volume cell manufacturing. Hence, we want to see how it compares to our current equipment as we scale. And is then the adaptation of our current cell recipes for that pan mixer to ensure they're also scalable. There'll also be an assessment. There is an assessment of potential productivity improvements and impact on the downstream line. And currently there's a digitization and implementation of our cell assembly work instructions. So that's using a 3D PDF. Scale-up objective 3 has been to maximize potential plant capacity. So AMTE and HSMI are currently generating a manufacturing and investment roadmap that will realize a scale-up target of 60,000 cells per annum and to align procedures within the gigafactory. So that's 60,000 of our UHP cells, to be clear. Key tasks include supplier engagement and equipment costing, a financial review of outcomes from other work packages, the development of a cost model that will enable scenario analysis, and the generation of the roadmap and scale-up strategy to make sure we achieve that target of 60,000 cells. So to conclude, the UK battery sector has domestic gigawatt hours for multiple gigafactory projects and is currently significantly undersupplied. AMTE Power has a unique position to scale and meet this demand with its UHP and UE cells, amongst others, but this is not without challenges. Projects that seek to collaborate and innovate, such as Thurso Plus, can have a major impact on UK SMEs like AMTE and our supply chain, so consequently can benefit the UK battery and automotive sectors. However, continued government and private funding must be committed to the battery sector to save it from offshoring, and providing it does so, the British style manufacturing has a promising future ahead of it. So thank you for listening, everyone. Please follow us on LinkedIn at AMTE Power and add me as a connection to discuss AMTE further following this conference. Thank you.
Thanks, Fergal. That was very interesting. Got a couple of questions for you that have come in.
Sure.
First of all, how far are we away from having cars that can be charged in the same time as filling them up at a petrol station?
Yeah, so that depends on the size of the pack. So current technologies are being developed. I think what is often left out of that consideration is whether we actually want cars that can be charged that quickly and whether that's a necessary requirement. And I think there's a definite need to change our thinking about mobility and not spending a lot of money on very expensive, extremely fast charger systems and considering instead improving charging at home, improving shared car schemes and sort of working on mobility more generally. In terms of the cells we're working on, we're aware of a few technologies that are working towards that, but everything I've seen personally is currently only at the lab scale, and we are waiting to see that demonstrated in a vehicle, in a real prototype vehicle, and acknowledging that when we see that prototype vehicle, then it will still be 3 to 4 years till production. So we'll know when we see it, but I think the lack of real world demonstrations does show really where the market is.
And you've got to have the infrastructure to be able to charge it that fast.
Yeah,
as well.
Exactly. I think oil and gas companies would love people to keep people at the forecourt, and what they're of course worried about is the change and the move away from people needing petrol forecourts at all, and rather charging at home using agile tariffs that can, and even looking at vehicle to load systems, which effectively is having people use their electric vehicles to support their domestic energy requirements. Which is, I think, what we want to adopt going forwards. I think we want to. I think we should only really think about that kind of charging in emergencies or on very long journeys. And I think it's a habit we want to keep. Great.
Are you doing any work specifically in controlling failure modes and reliability and allowing the safe decommissioning of individual cells or stable degraded performance?
Sorry, could you repeat that? That's quite,
yeah,
quite a long question.
yeah. Are you doing work specifically in controlling failure modes and reliability, and then allowing safe decommissioning of individual cells or stable degraded performance?
Yeah, so I know at the AMTE plant we are conducting FMEA analysis on our current cell production. I don't personally know the detail of that, but if whoever asked that question wants to contact me and discuss that further, I can bring the right people on board for that conversation.
Great, thanks. Another one. Are MTE batteries suitable for utility scale energy storage? And secondly, what's a realistic timescale of delivery?
Yeah, so we're working on two variants of our ultra energy cell. So we're working on an NCA chemistry focused on the electric vehicle market, so a high energy density. We're also looking at an LFP variant of our cell for stationary storage. In terms of delivery, again, that's I would have to check when our current targets for release of sample cells are. But again, whoever asked that question, if they could drop me a message, and then we can set up a conversation to discuss that further. I think the hope is this year, but I would need to confirm. That.
Great. How are you comparing current mixer with PAM mixer? What are the scale-up criteria?
Yeah, so unfortunately, again, it's really a question for a colleague of mine, because whilst I wrote the first surplus bid, I haven't heavily been involved on the project. We're due to release a Q1 sort of update and results report from the Thurso Plus project. So we will be sharing that on our LinkedIn feed, and it's something I'd be very keen to share with the Silverstone TC group as well, to see any interested members can sort of read up about that. So hopefully we should have the details shortly.
Great. A question from me as well. Have you seen a difference in the amount of inquiries you're getting from cells sort of post Brexit, and more people looking at the UK supply chain possibly rather than Asia?
Yeah, so I think it's security of supply has come to the forefront of a lot of people's concerns and criteria when picking cell supply. I think previously it was a focus purely on pounds per kilowatt hour cost, with almost a relative complete disregard to any other criteria whatsoever, which is why the pounds per kilowatt hour figure is the one we see so prominently in every conversation. But what's come, I think that security of supply, especially with, without getting into it too much, the global political issues that have been happening in terms of supply out of China and the related supply chain in cell manufacturing, we're finding a lot of battery production and vehicle production companies and stationary storage companies and also governments are very keen on onshoring their supply. So getting hold of that security of supply chain, especially because we're on the verge of a boom in requirement for lithium and lithium-ion batteries, that having that security of supply domestically is going to be a huge benefit to whoever has it, and to whoever doesn't have it and doesn't have that security of battery supply. I think it's going to be very difficult. As we've seen already, electric vehicle production has been stymied by the lack of supply of lithium-ion cells. Even for companies like Tesla, demand far exceeds supply capacity. So that's only a problem that's going to increase going forwards.
Okay. Is module and pack manufacturing on AMTE's roadmap beyond cell manufacturing?
So we do work very closely with integrators. Quite a few of the ones who are actually on this conference as well already. For example, Delta and the niche vehicle project, niche vehicle battery project. In terms of module and pack manufacturing, it's not something I could comment on. Our current strategy is focused on the development of our ultra cell technologies and scaling up to gigafactory production. And that requires a huge amount of effort as it is. So that's our current focus.
And just another question from me: raw material availability. Are you still being able to get a hold of raw material fairly easily, or is the demand starting to outstrip supply? We are, and we have quite intensive sort of economic
models, and we work closely with research groups to ensure that we're securing that going forwards. So it's something we're very aware of, and the R&D projects we do, they help a great deal with doing that groundwork for creating models and preparing to know what your demand's going to be. So rather than go into it blind and then be shocked by the lack of that raw material supply, we're able to plan for it and using the outputs of these R&D projects as a basis. So they proved really valuable in our scale up.
Excellent, great. Thank you, Fergal. That was really interesting. Thanks for that.
Great to see you.
Yeah, speak to you soon, hopefully.
Cheers, everyone.
Thank you. So I'd now like to introduce the last speaker for today. So I'd like to bring on Andrew Britton. He's the Business Development Manager at the UK Battery Industrialisation Centre, who's going to give you an introduction to UKBIC. Hi, Andrew.
Thanks very much, Simon. And hello, everybody. If I can just share that screen.
Your camera's off as well, Andrew, just so you know.
Okay, oh, yeah, there we go. Thank you. Right. Can you see my screen?
Yes, we can. I don't know if you want to go into presenter mode.
Yeah, I am.
Brilliant.
Okay, everybody, welcome to the UK Battery Industrialisation Centre. I'll give you a bit of background as to how we came about and our raison d'etre, the progress that we've made with the project so far, and describe how we're moving into what we are calling business as usual, which is our transition from a project to make a company to a company that is making product.
Sorry, Andrew, could you change your display settings very quickly so we can see the full screen slideshow, please?
Oh, right. Sorry, I didn't realize you couldn't.
Yeah, if you go to the top, the second option, display
settings. Sorry. Yep.
And the swap thing. Wonderful. Thank you. Sorry to interrupt.
All right. Sorry about that. Technology always defeats me. So, back in 2017 and probably a little bit before, the UK government recognised that if the automotive OEMs who were located here didn't have access to the batteries that were going to be needed in the future, there was a high possibility that those manufacturers would relocate their manufacturing facilities to companies and regions where the batteries were available, and that with the consequent loss of tens of thousands of jobs through the automotive OEMs and the associated supply chain. So they created the Faraday Battery Challenge and allocated a sum of £318 million of funding to develop the design, development and manufacture of batteries for electric vehicles. There were three strands to the Faraday Batteries Challenge. The research element, which is utilising the skills of universities and industrial partners to look into the research element of battery manufacturing. So battery degradation, recycling, reuse, electrode manufacturing, cathode materials, solid state batteries, which we've mentioned before, sodium, which seems to be on the rise, and lithium sulfur batteries. The second strand was innovation, which was creating new solutions through collaborative partnerships. And that was with the idea of bringing companies together to develop applications for the results of the research. And then at the far end of the scale, there was a requirement and an acknowledgement that those projects wouldn't lead to immediate gigafactories unless there was some element of scale-up capability within the UK. And hence the UK Battery Industrialisation Centre was formed. So out of the 318 million, we were allocated eventually through a couple of stages, 130 million pounds of that funding to create the facility. That was funded by the Faraday Battery Challenge, and also West Midlands Regional Investment and LEPS. And it provided a scale-up program to allow companies of all sizes to rapidly move into new battery technology, to bring new battery technologies to market. And it was to help companies developing the manufacturing tools and processes for mass production, and provide a skill off the back of that, to provide a skilled workforce capable of manning the gigafactories of the future. So looking at the relative scales of the Faraday Battery Challenge, you have the gram scale, which is typically university scale research labs. You've got the kilogram scale, which is sort of corporate R&D pilot lines, or again, larger university projects. And then at the right-hand side, you've got the gigascale. But I've worked in environments where the gap between kilogram and gigascale is called the Valley of Death. And the UKBIC is there to prop companies up to cross that Valley of Death and make it from kilogram to gigascale battery production. So we've been set up to have full-scale manufacturing facilities, which are exactly the same as you would find in a cell manufacturer or a module pack manufacturer in any gigafactory in the world. So we've got the same amount, same kit, and we can use this to develop and validate materials and manufacturing processes and training right through to full plant investment. But what we also do is provide a manufacturing environment where we can take on the early stage production manufacturing while your gigafactory is being built. So you're deferring some investment in your gigafactory until you know you've got a product that actually works, and you've got all your investors on board, and they can see that and they will invest because they know that they've got a product that they can believe in, and you can also generate revenue from the sale of the product that we're producing to make a start. So typically we operate in manufacturing from TRL 6 up to TRL 8. So we're not a design facility, so we can assist with optimization of designs and processes, but we expect our customers to come to us with a relatively robust and developed design, and then we can put that into manufacturing for you. We're also involved in quite a few consultancy type projects, which actually bleed us back into probably the TRL 4 to 5. So what we have is a 20,000 square metre manufacturing and research facility. It's just on the outside of Coventry. Some of you may have noticed it if you live in the area. Right next to the airport. Very easy to access, in the heart of the Midlands and in the heart of where a lot of the automotive industry is located. So we've got a full suite of facilities, so everything from electrode, cell, which is 21700s for cylindricals and 300 by 100 VDA standard pouch cells, and then also module and pack manufacturing capabilities at industrial rates, but with quite a lot of flexibility built into them at the moment. So we are a learning factory. So although we can operate almost as a subcontract manufacturer, that's not really what we intended to be. So when we are manufacturing, using our facilities to manufacture product for clients, the real aim is that the client will have their own staff on site working alongside us, so that they're learning the processes and the manufacturing techniques and the use of the facilities and how they work, and helping to do them through that process to develop and optimize new manufacturing processes, coming to us with new materials and establish whether they are actually feasible at manufacture at industrial scale. We can look at new cell formats, although I've said that we have concentrated on 21700s and 300 by 100 pouch. We are talking to clients about prismatic and solid state manufacturer, and we do have space protection, as I'll come to on the next slide, to bring those technologies in when the time is right and the market need has been established. And then we can also look at module and pack structures. So we're reducing commercial risk for high volume manufacturing by proving everything out. We're an open access facility. We promote UK industrial collaboration for organisations of all sizes. We're talking to some very major organisations and also some very small organisations, but who are at a point where they're moving from concept through prototype and into production. One of the more unique aspects of UKBIC is that we never intend to own any IP. So if clients, engineers are working with us and IP is created as a result of that collaboration, the IP will always stay within the ownership of our client, not with UKBIC. And we will also, we're also developing training packages at a very rapid rate now, in collaboration with some of the major automotive OEMs and tier 1 manufacturers to support the growth of the UK battery industry. And that is something that will be rolled out over the next 3 to 4 months. In terms of a look at the facility that we've got, the bottom picture is actually a schematic of the facility, which is 270 meters long, so about 150 meters wide. It is a horseshoe operation, so everything comes into the factory through the left-hand side and exits through the left-hand side as well, through our logistics hall. So we have mixing, we have high intensity mixers from a company called IRIC. We've got 2 of those, one for anode and one for cathode. We've got coating and drying. We've got 40-meter long dryers with 8 separate temperature controlled areas, with dry rooms and low humidity rooms with extremely low dew points where that is required. Then we have calendaring, slitting, and then pouch assembly and cylindrical cell assembly. In terms of capacities, we can coat at a maximum of 40 meters per minute, and that's simultaneously double-sided coatings. Obviously, the speed depends on the coat weight and the material that we're utilizing, but 40 meters per minute is the theoretical maximum. Then we have a pouch cell and cylindrical cell formation agent test. That's a very extensive facility in comparison to the facility for cell manufacturing, because FA&T is quite a lengthy process. So we need to be able to have enough space within there to store and have a lot of cells being tested and aged at the same time. Then if you're just manufacturing electrodes or cells, your material will exit left. But if you are using our module and pack assembly lines, we have what we call agile lines, in that they're quite low on automation, but very high in flexibility. So we're able to accommodate a large variety and size of modules and packs. Pack size, we can do the typical automotive pack at sort of 2.5 meters long, a meter and a half wide, and half a meter high. And we can adjust. The current line can produce around 2.5 packs a day on a single shift of 8 hours, and we can produce around 100 modules per day on an 8-hour single shift. Now, customers can come to us for electrode coating only. We're working on a project at the moment where we're running some electrode through, which the customer wants to calendar themselves, so they can take it out at that point. we can do the slitting and then ship daughter rolls of the electrode material to and cylindrical cell assembly. Currently, we can do 20 cells a minute on cylindrical and 2 cells a minute on pouch. I should say that although the cylindrical cell assembly facility is installed and working, COVID has slowed us down on the pouch cell assembly, and the assembly equipment is arriving on site this week from South Korea. As you can see, there is an expansion area down the middle where we can put in additional technologies. We can also install what we would call a runner line. So if companies wanted to manufacture higher volumes of module and pack beyond the capability of the agile lines, we do have the capability and the space to put in a higher volume, higher automation manufacturing facility. So UKBIC use cases include making to print, where you come to us with a complete design and you just want us to manufacture it, although we would always take the design and assess it for suitability for fit on the equipment and safety through the facility before we put it onto the equipment. We can prototype at scale, so beyond what you would find at a research facility or a pilot line, but still prototyping at higher levels of volume. We provide knowledge transfer and skills development. We have 90 engineers on site now. Well, 90 staff in total, of which the vast majority are engineers who've come from a variety of backgrounds in the electric vehicle battery space, or the battery space generally. We get involved in a lot of collaborative R&D projects. We'd also take on quite a lot of commercial projects, and what we're trying to find is a good balance between collaborative R&D and commercial, because although we are currently government funded, in the longer term we will be expected to cover our own costs. So we have to find a way of balancing how much our collaborative R&D we can take on and meet the requirements of the costs of running the facility. And then we are kind of reluctant consultants, really. I don't think when we were formed, the idea was that we would be a manufacturing facility, but the first funded projects that we've had from the commercial world have been people who've wanted us to work on optimizing their designs. So design for manufacture and design for assembly is quite an important part of our role, and it is something that will be there going forward. In terms of the customers, we were created to maintain production of electric vehicles in the UK, and that's still the case. But our potential customer list now encompasses all forms of propulsion. Automotive is still very important, but we're getting a lot of interest from the aerospace sector. Off-highway vehicles, quite a lot. Yeah, indeed, some marine, some marine that's both on the surface and subsea, and a limited amount at the moment, admittedly, of interest from the rail sector, but a huge amount of interest from energy storage for both the commercial grid, the national grid, and domestic services. Warehousing and robotics, there's a lot of development of lithium-ion batteries for that sector. And then we also, of course, support battery sector manufacturers and tier one producers. And we also have a role in helping to establish a full supply chain for materials and equipment and components. So then move next. So just some general pictures of the facility that we have. just to show you, because you'd be amazed how many people still say, yeah, but are you real? Yeah, we're real. We do exist. We've got a finished facility now, with a really nice working environment, a nice place for our customers to come and work. The one that the picture on here that I would point out is the one in the middle at the bottom, which is our customer campaign room. We have 5 of those, which can be configured in different ways, where customers can come and base themselves while they are working on our site, in a totally confidential and secure environment. So just a little bit of a look at the equipment that we've got. Mixers are from IRIC. They're quite high volume. They're 220 litre capacity mixers. We can bring in smaller mixers for smaller batches of electrode if required, but our standard is for anode and cathode is 220 litre capacity. Megtech coaters. And winders, so it's reel to reel, maximum foil width of 700 centimeters. Hang on, sorry. Yeah, 700 millimeters. I beg your pardon. 700 mil width with 680 mil of coating capacity. We've got slot dies. We can change the coating pattern. We have established our own UKBIC reference cells, which we can allow people to use for testing of their materials if they want to establish benchmark versus our reference cell. Then we have our calendaring equipment, which Emma talked about in her presentation. So we can do this at scale, at industrial scale, and then slitting up to 8 ribbons of daughter roll. And then on the right, we have the drying facility, which I said is 40 meters long and has 8 separate zones for drying temperatures. There you can see a picture of the daughter rolls that we're producing, the cylindrical cell equipment, which is in and running, and then on the formation agent test equipment is a lot further advanced now than it was on that picture, which was taken in December. And there is a UKBIC manufactured 21700 cell. You might have seen on LinkedIn and associated media in the last few weeks that we are trumpeting the launch of our module and pack assembly area. This is something which is now fully on stream and commissioned and available for use, and the first customers are now in and using it. So as I mentioned, it's relatively low volume but very high flexibility, and we focused at the moment on laser welding, but other welding technologies can be brought in if required. Pulse arc has been mentioned earlier in the presentation, and ultrasonic welding is something that we've been asked to consider for another couple of projects. And that's about it from me.
Thanks, Andrew. Couple of questions. Actually, one of them I was going to ask myself, but with regards to knowledge transfer, are technical tours of your facility available, or are they only for customers?
We will be inviting a wide range of people in when the current restrictions allow. So yes, we are expecting to get engagement with educational institutes who want to bring students in, apprenticeships, and colleges, and industrial partners who just want to see what we've got, because you never know where those contacts will lead. So yes, we will be.
Excellent. Another question around, do you have access to any mixing know-how outside of the mixer suppliers, and how did you choose the mixing kit that you've installed?
I can answer the second part better than I can answer the first. So if the person who answered that question would direct it to me through the info line that you can see there, I'll I will get that question answered. The mixing kit was chosen because we needed a high intensity mixer for mixing the slurry that we'd identified, and the best one out there. And the kind of industry standard at the time that we bought it, and I think it's still the case, was the IRIC mixer.
Okay, excellent. And actually, a question from me as well. Have you considered, or would you consider in the future, the reverse engineering of cells that may now be obsolete? Obviously, one of the issues that does crop up is cells go obsolete, or in either size, format, or type, or manufacturer. Is that something you may consider?
Yes, I think we certainly could. As I say, in terms of our remit, that would fall quite nicely within it. We're about creating a sustainable future for UK battery manufacturing. So, if that is a requirement of the industry, then yes, we would certainly consider it.
Excellent, great.
Could I pop in with a question, please, Simon?
Yeah, go ahead.
I mean, fascinating presentation, really interesting. Obviously, you're well set up to support companies in a fantastic manner. When it comes to funding and things, do you provide any support or guidance to help people find funding or source funding or anything like that at all?
We can work on collaborative R&D projects, as I mentioned. We're unable to fund projects ourselves. We are prevented from doing that. Being fully, certainly at the moment, we're fully funded by UK government, so we can't sort of invest money in projects ourselves at the moment. But we can get involved in collaborative R&D through the many funding streams that are available in the UK, and yeah, we can guide people in the right direction as to what's available and what for.
So definitely a bit of signposting on where they could apply.
Yeah, we can do that. We have done that.
Yeah, thank you.
Excellent. I think there's only another one's just come in. Are the customers you refer to cell manufacturers and R&D entities? I ask that because it becomes strange that UKBIC would be talking to OEMs and the like that do not make cells or develop that technology.
Well, we do talk to OEMs who are interested in module and pack. So that's where our involvement with those are, because a lot of them are looking at doing their own manufacturing. What we get involved in quite a few times now, and it tends to be at an OEM level, is a make or buy decision as to whether they continue or to import batteries from largely Asia, or whether it's feasible for them to set up manufacturing of their own in the UK. So that's the OEM involvement. But yeah, you're right. On a cellular level, it's the cell manufacturers that we tend to be talking to, and also material developers. So people are coming to us saying, can we put our novel electrode into your standard reference cell and see if it works? So we do quite a lot of that as well.
Excellent. Another question just come in. Will you have a way to facilitate networking between your customers or other companies interested in technologies developed with you?
It's possible. Obviously, everything that we do has a high level of confidentiality attached to it, but through non-disclosure agreements and with the agreement of all parties that are involved, yes, we could facilitate that.
Excellent. Very good. Okay, Andrew. Thank you very much for that.
You're very welcome. Thank you, everybody.
Some great pictures there as well. So hopefully, with some COVID restrictions being lifted, some of us can come and have a look.
You're welcome anytime, Simon. As soon as it's legal. Brilliant.
Thank you very much. Thanks. Okay. So I've just come to draw the presentation session to an end now. We've got another networking session to carry on after this, but I hope you've all enjoyed today's event. I think you'll agree we've had some really fantastic presentations, and I'd like everybody to join me in thanking the speakers and the Silverstone Technology Cluster staff for actually organising the event. I hope it's been beneficial to everyone. We've heard from companies involved in batteries from the early stages of cell development and manufacturing through design, prototyping and into volume manufacture, and then the recycling at the end of their life. So the whole cradle to grave processes of batteries. We've had some great questions during Q&A, which has been really good because I haven't had to think of lots of them up. So that's great. And thanks for keeping the speakers on their toes. If you have found this event useful, please keep your eye open for future special interest group events, as well as the other cluster activities, which there's lots of details on the website. And please, can you provide some feedback on the event via the mini survey that will actually be sent out to you. Silverstone Tech Cluster offers lots of opportunities for businesses and a focus point for the peer-to-peer networking. And if you're not a member, please can you consider joining. The membership is good value for money, and it includes things like the Mentoring for Growth and the advisory board programs that are provided through the partnership with Be the Business. I hope you all found the networking sessions earlier of benefit as well, made lots of new contacts. We have another breakout session planned now, so if you can, please stay online. I know we're probably keeping you all from your lunch, and make the most of the opportunity. Thank you very much for attending and making it an enjoyable event. And I look forward to seeing you all in the future, and stay safe and well. Thank you.
Thank you very much, Simon. That's fantastic. Well, I'd like to add my thanks to you for hosting this event. I think it was great. Thank you very much. Really appreciate it. There's one particular thing I wanted to highlight, especially to this audience. We have another special interest group event coming up on March the 16th, which is all about Brexit implications and opportunities. And with one of the speaker conversations I've had for that event is that with the Brexit regulations and specifically towards the automotive, where they're moving towards sort of a net zero scenario, it has actually created a very interesting opportunity for UK companies and suppliers to where there's a real increased opportunity in terms of sourcing from the UK and bringing things in that way. The speaker that we have lined up at that event will clearly do a much better job of explaining that than I just have. But it should be a very fascinating session, and especially if you're in the automotive supply chain, I would very much recommend to attend that event as well. So that's on March 16th. It's the title is Brexit implications and opportunities. But if you go to silverstonetechnologycluster.com on our events list, you will find it there, and I would definitely recommend booking off of that. Should be very interesting. Of course, do please check out the website for all the services that we offer. Clearly, I second Simon's thought that you should all join if you haven't already. But then I would say that, wouldn't I? But thank you very much for attending. Simon, thank you very much for hosting. I think this has been really great. As Simon said, we'll now open up the social lounge again, so you can all network, and we'll keep that going until about 1:30, should you choose to network and things. Yeah, thank you very much for attending. Hope you found it really good and enjoyed the networking, and we'll hope to see you at the next one. Thank you very much.